All right, so for today, for the lesson, everybody's attention up front, please. I want to make sure we have enough time at the end, so you need to stay with me. Shh. Get your pens and pencils out, get ready to write, get ready to roll. Okay, we're going to do quiz 6.1, but we're going to do it in the rotation because I need to make sure you guys are understanding this, so we are going to do a modified rotation. You can sort of see on the board, on the green, you're going to work together in your groups. Hopefully you'll be able to get help from each other. Red is going to be help from me and where you report your quiz. And then blue is where you're going to be 6.1 and basically working with just you and your partner to get stuff done. We are going to be putting together everything we've learned in the last 2 units and adding on to it. So if you have not done well on the last 2 units, come in during tutorial on Friday, come in during tutorial on Monday. Okay? And I'll even do Wednesday. We'll go back over the old stuff, so hopefully you can get on to the new stuff. Okay? So you can get some help. Daily work 6.1 will be due at the end. This is what we're learning about. Man, the stoichiometry is boring me stiff. Maybe it would be help if I had arms and could read more than the first page. Basically, stoichiometry is using our equations that we've been doing in balancing like a recipe. So we can find out if I put this much in, how much can I get out? Okay? So this is what they use in industry to figure out if I need this much in the end, how many of each of these things do I need to mix together in the beginning to get that? Just like a baker tries to figure out how much flour, how much sugar, how much chocolate chips they need to order so they can make this many chocolate chip cookies. Okay? So that's what we're going to relate it to. Going forward, come on, there we go. You need to know what stoichiometry is. So this is the first thing you need to write down. It is a vocabulary word. Makes you sound smart. It is the study of the quantitative, meaning the amount, relationship between the amount of reactants used and the product formed by a chemical equation. In other words, how much of the reactants make how much of the product. So you don't have to write everything down, but just get the main idea of this. So how much of the reactants will make how much of the products. That's the easy way to remember it. Quantitative is just a word that we've used in our vocabulary before, meaning an amount, right? An actual amount, some number that I can write down. Okay? Let's see if I can get my Christmas tree to light up today. We have a short in this wire and it just doesn't want to light. Ooh, now it is. Okay, just have to hold it just fancy. Hopefully it won't distract you too badly. So how much of a reactant makes how much of a product? That's basically what you need to know stoichiometry means. The easy version. You okay to move on? How much reactant makes how much product? Okay, so basically, like I said, it's like making stuff. Okay, so if I want to do a cheese sandwich, how much bread do I need with how much cheese to make the sandwich? Suppose I had 10 slices of bread, 10 slices of cheese. How many sandwiches could I make? 5 if you go wimpy on the cheese, right, with just 1 slice. If I want 2 slices, then how many sandwiches could I make? 5. Okay, all right, so what's the limiting ingredient? We don't have one here. We're going to, well, excuse me, yes we do. What are we going to run out of? Bread. That's the limiting. Okay, so making stoichiometry easy. If I wanted, how many slices of bread do you need to make 7 grilled cheese sandwiches? So this is something you do, if you need to make stuff for the family, it's something you do. I need 7 grilled cheese sandwiches. I need 2 pieces of bread for each grilled cheese sandwich, so I need 14 slices of bread, right? That's the easy thing. What happens when I get to chocolate chip cookies? Well, it's not just one thing now. I'm working with several different things. I need 1 cup of flour to 4 eggs to half a cup of sugar to a cup of butter to half a cup of chocolate chips, and that'll give me 12 cookies. So that's a little bit more involved. So what if I want 24 cookies? I double the recipe, right? Okay, so this is sort of what we do in chemistry with our chemical reactions. So here's a chemical equation that we did. It's a recipe. I need 1 nitrogen to go with 3 hydrogens to make 2 ammonias. Okay, Now, it's a ratio or a recipe. So we're looking at a chemistry recipe for a chemical reaction. Okay? It helps me to understand what's going on. This is the next thing that's in your notes. If you want to write that down, that's great. Okay, so that equation is in your notes. It's just a ratio or recipe. If you think about it like a recipe, it's not that hard. Okay? If you think about it, oh, it's chemistry, it's stoichiometry, sometimes it gets a little overwhelming. But if it's just a recipe to make it, not a big deal. Okay? So, we're going to use this equation, the balanced equation that we had on the other page here. And by using the equation, how many moles, and this is what I do when I'm doing this, okay, how many moles of hydrogen, so I'm wanting to know how many moles of this are needed to react with 2 moles of nitrogen. So I'm just asking how much I'm going to need to react. Well, if we go ahead and start this, we always start with what they gave us, just like we did before. Okay, so 2 moles. I'm going to set up my factor label like before. I want to get rid of 2 moles. So this is where I look at the ratio, what I use to balance the equation. In front of nitrogen is a 1, so I'm going to put 1 mole of nitrogen on the bottom. In front of the hydrogen, which I want to get to, there's a 3. So I put that 3 moles on the top. My moles of nitrogen cancel out. Now, because they cancel out, I'm able to just times through and find out that there are 6 moles of hydrogen needed. Okay? Very simple, easy math, right? So if I have 2 moles of nitrogen, I need 3 moles of hydrogen. I put too many moles of hydrogen, sort of ignore a row here. And it gets me 2 moles of ammonia. Okay, so going forward, we would have, I was showing the one above. This is another one that we could do. If I have 2 moles of N2 and I have 1, 2, 3, 4, 5, 6 moles of hydrogen, then I can make 4 moles of ammonia. All right, so how many moles of N2 are needed? So again, didn't we just do this? Do I have 2 of the same slide? No, they're different. Okay, how many moles of N2 are needed when to react with 3 moles of hydrogen? So again, start the same way. 3 moles of hydrogen. We're going to put what's in front of hydrogen on the bottom this time, 3 moles. And we're trying to get to nitrogen, so 1 mole on the top. Moles will cancel out. And if you'll notice, the 3's will cancel out too, right? 1 on top, 1 on the bottom. So it's just going to be 1 mole. So simple, easy math. Let's see if I've got these made right. So I think I've got these backwards. I do. This should have been on the previous one. Okay, yeah, this is messed up on the bottom. Sorry, I'll have to go back and fix that. Okay, going on to the next one. How many moles of NH3? Now we're crossing the arrow. So over here, how many moles of NH3 are produced when, now we're not using whole numbers. 2.5 moles of N2 are used. And excess hydrogen. So I have excess, I don't need to worry about hydrogen, in other words. I don't even think about it. So I'm going to use the numbers in front. Start with what I started with. The number in front of nitrogen is a 1. So I'm going to put 1 mole of nitrogen on the bottom. On the top, since I want to go to NH3, I use the number in front of NH3. 2.5 times 2 is 5. So we should end up with 5 moles of H2. And in order for this reaction to happen, we actually have to have a catalyst. And a catalyst is like a matchmaker. We'll talk more about catalysts later. This is just a little picture to show you how that reaction works. Did you see how I got it?
I was just confused about the H2. Like, how did you know to put H2?
Oh, that shouldn't have been H2. That should have been, sorry, NH3. Thank you for catching. I was trying to make this really fast. You can tell there's a lot of errors. I'm sorry. Okay, we'll go fix them. Okay, so now we're going to the next page. We're using something we've done already. Balance that equation quickly as you can. Fast as you can, balance that top equation. I'm going to give you 30 seconds. Go. $15 seconds left. Look up to me when you got it balanced, so I know you're done. 10 seconds. 5 seconds. 2 and 1. Okay, who would like to volunteer the coefficients? Bailey. Okay, what'd you get? 6? 666? Is that correct? Oh, no? Okay. Okay, so who?
I got it.
2, 2, 3. 2, 3. Okay, does everybody agree with this one? All right, so before we start any stoichiometry, before we start any stoichiometry, we have to have a balanced equation. If we don't have a balanced equation, DJ, then we can't go on. Okay? So we need to have a balanced equation. In order to use the balanced equation, we have to have whatever they give us in moles. We can't use the balanced equation unless we're in moles. So it's like somebody giving us a recipe and then they give us butter that they bought in Europe where it's not in pounds. It's in grams. I first have to figure out how many pounds are in that gram so I know how much to put in my recipe. Okay, does that make sense? Okay, so let's go forward. How many moles of oxygen? So again, right underneath where the equation is, I say, okay, I'm trying to get here. So how many moles of this are produced by the decomposition of 6 moles of potassium chlorate? By the way, potassium chlorate is what I showed you in the hood right before Thanksgiving when we did the sacrifice of Gummy Bear. Okay, so that was a firework that we did in the hood. All right, so again, start with what they gave you, and you just do the factor label again. What they gave you, you're looking at this number right here in front of potassium chlorate. That's going to go on the bottom, so you can get rid of potassium perchlorate. And what you want to go to, oxygen, that number goes on top. Okay, we can cancel out moles of potassium chlorate. Then if you go 6 times 3, that's 18. Divide it by 2, you get 9. Yes?
So in this one I see you got the numbers just from like the balance of the equation.
That's what we did the last time too.
But how did you know what the numbers were of the last ones?
It was given as a balanced equation.
Oh.
So this time we had to balance the equation before we used it. Okay, good question. It's good to know where things are coming from. So easy, we can get 9 moles of oxygen off that. Okay, so I just brought that equation we balanced from the other page, our other page up here, but you can still see yours. How many moles of KCl? So again, right underneath KCl, I'm going to go question mark moles, are produced by the decomposition of 3 moles of potassium chlorate. So again, start with what they gave you, 3 moles of potassium chlorate. And we're looking in front of potassium chlorate to get the ratio. So we're going to put 2 moles of potassium chlorate on the bottom so that we can cancel out the moles of potassium chlorate. Then we look in front of what we want to go to, and that goes on top. Well, here, the moles cancel out, and so do the 2's, right? 2 divided by 2 is just 1. So how many moles do I get? 3. Okay? Pretty easy so far? Okay, we're going to add something into that. Okay, remember when we had to add up molar mass? Okay, we're going to be able to have to do that again. So, we're going to take a carbon, we're going to take 2 oxygens, and we're going to add it up and get a mass. And we know that mass is equal to 1 mole. So this is carbon dioxide, CO2. Okay, we're going to be using this later, so we better write it down real fast so you don't have to add it up later. Whenever it has grams, whenever they give me grams, I always have to change it into moles before I can do that ratio. Okay? So it's like somebody giving me a liter of milk, and all I have is measuring cups in liters, and half a liter, and a quarter of a liter. I don't have cups. I need to know how to convert it. Okay? So I have to convert it into moles before I can use my recipe. So, going forward here, remember our mole map? We're going to be using it again. Because whatever they give us, if they give us atoms, I've got to convert it to moles. If they give me grams, I've got to convert it to moles before I can use a balanced equation. Okay? So, the yellow mole is where we're going to try and get to before we use the balanced equation. Okay. So, this looks really funky. So stay with me. I have to get it to moles before I use the equation here in the center to go from moles to moles with my ratio. Then once I get moles of something new, I can change it back into grams if I need to, or back into atoms if that's what they want. Okay? So this right here actually simplifies down. So I use my balanced equation to get mole ratio. This actually simplifies down to this. We have not worked with volume, so you don't need to worry about the bottom part. All we've done is gone either mass to moles or molecules to moles, right? So this is more of a simplified thing. When we get to gases, we'll add that in, but we're not going to add it right now. But the ratio right here, I have to do moles to moles, okay? So if they give me grams of oxygen, and they want to know how many grams of methane it can make, or whatever on the other side, I have to get it to moles first, then use my balanced equation to go from moles of one thing to moles of something new. Then I can take that moles of something new and change it back into grams or into atoms. Now we're going to practice that. So, here's another equation. You got 30 seconds. Let's balance it. It is what type of equation? Combustion. Kaboom. Yep, combustion. About 15 seconds. Remember, when you get done, look up at me. Yes? Oh, we've got a new one. You got to go grab the new one. We took a test last time, remember? And I'm on the second page in. Second white page in. Here. Okay, who can give me the coefficients going across the top? Yes, what are they?
1, 8, 6, 5.
1, 8, 6, 5. Do I have a second on that? Yes, all right, here we go. Let's read the question. Shh. Let's read the question. I have 1.50 moles of pentane. It undergoes complete combustion. How many grams of O2 will be needed? Okay, so this is something new. We can't stop at moles, but we always start with what we're given. Since it started with moles, I can go right to the equation to change from pentane to oxygen. So, start with what I'm given. I put the coefficient of what I was given, which is a 1, because we don't write ones, on the bottom. I put the coefficient of what I want to go to on top. At that point, I can cross out moles of pentane. but I'm not to grams yet. See how I wrote what I need to get to so I know if I'm done? So the next step is just what we've done before. I need to go from moles to grams. So I put 1 mole of O2 on the bottom, and the mass of O2 is basically 2 times 15.999, which is oxygen, right? I've done that already for you. It's 31.988. The moles of oxygen would then cancel out. That should have come up first, sorry. Moles of oxygen cancel out. And then we just times through the top because all the numbers on the bottom are ones. So we take 1.5 times 8 times 31.998. By the way, if you didn't pick up a calculator, now would be a great time to do that because you're going to need it today. Or get one out. And you might want to get your periodic table out too because we're going to be adding up formula masses. Okay, we have been given 1, 2, 3 significant figures. So we want to write down 3 significant figures for the end. So as soon as somebody gets the answer, would you raise your hand and let's see if we get it right. Just timesing through the top because the numbers on the bottom are 1. Okay, you helped me already? 383, do I have a second? No. Okay, redo it. Let's see if what did you get? 384. Ooh, those are close. 383 or 384. What's the difference between the two?
I rounded up.
Didn't round up. Okay, let's see what I've got up here. 384. Good. So when you need 3 significant figures, you always have to look at that fourth one and see if it's going to round up or not. If it doesn't, then you just truncate. Okay, going forward, we've got that formula again. I brought the balanced equation forward. This time, we're starting with 80 grams of CO2. And we want to know how many moles of O2 we needed. Okay, so this time I can't go right to the equation. I've got to change the grams to moles. Right? So I'm going to set up my thing, and I got to add up CO2. Remember we did that earlier. I told you to write it down. So we can just take and put it right in the equation. Grams on the bottom, so they'll cancel, and I put 1 mole on the top. Okay? Now I can go to the equation. There's a 5 in front of CO2, and there's an 8 in front of O2. So I want to get rid of CO2. I put the 5 CO2 is on the bottom. I put the 8 moles of O2 on the top. Then, remember, I've got more than one thing on the bottom. So I put in my calculator, I'm going to divide, parenthesis, times through, close parentheses, hit equal, and when you do that, let me know what you get for an answer. I want a new helper, somebody that has not helped me before. Yeah, so you times through the top, and then you hit divide, do parentheses, times through the bottom, close parentheses. Yes?
So how do you know that's equals, like how do you know that's equals for O? Okay.
I'm using the balanced equation. So the coefficients become my ratio. How much of each one do I need? Just like the 2 bread to 1 cheese. Okay? So times through all the way through the top, 80 times 8 divided by parenthesis, 44.0909 times 5, close parentheses, hit enter. Okay, who thinks they've got the right answer? Anybody else besides Sam? Nobody? Okay, DJ. 2.91. Do I have a second on that? All right, let's see. Oh, I didn't cast that out. 2.91 is right. Great job. Make sure you label it. Don't leave any naked numbers. It's moles of O2. So you can see now that we're changing from compounds to new compounds, it's really important you keep the labels on your numbers. So if you don't, we don't know what that is. 2.91 moles of what? We've got a whole bunch of things we could have moles of. Okay, here's our equation again. We want to produce now. We want to produce 2.75 moles of water. How many grams of pentane would be required? So we're going to always start with what we're given, 2.5 moles. Since it's in moles, I can go right to the ratio, right to the equation. I want to get rid of water, so the 6 moles of water is going to go on the bottom. I want to get to pentane, so the 1 mole of pentane is going to go on the top. Before I move on, I should make sure that the moles of water cancel, and they do. One on the top and one on the bottom. Now I'm in moles of pentane. I got to add pentane up. So you would add pentane up just like you did before. So 5 times carbon plus 12 times hydrogen, and you end up with 72.15 grams of pentane is equal to 1 mole of pentane. And I walked away because I know it takes a little bit of time to walk that down. You just can't do it with a click, like me. But like always, this will be recorded and put up on Canvas so you can go back and look at it if you missed any of it. Okay? All right, so going forward, I'm now going to put 1 mole on the bottom, and I'm going to put that mass I added up, that 72.15 grams on the top. My moles of pentane cross out, and I end up with grams, which is what I wanted. So I can stop. On this one, we only have 1 number on the bottom, but if just get in the habit of when you do if you have something on the bottom, divide, parenthesis, times it through, close parenthesis, and then hit your equal. Go ahead and do that, times through the top, divide, parenthesis, times through the bottom.
Wait, so can you tell me how you times and divide it?
So you just times through the top, so just times all the numbers through the top.
5
Times 1 times 72.151. You really don't have to put the 1 in there, right? Because anything times 1. Then divide by, it would just be 6 on the bottom here. Now, if I have more than 1 number, I got to make sure I put it in parentheses. So I just said get used to putting it in parentheses. It's not going to hurt it if you don't need it, but it will save you when you do need it. Okay? Who's got an answer? What do you got? 33.1. Do I have a second on that? Ooh, I see some shaking heads. Yes. So I actually did not look at me. Ooh, I did not do the right number of significant figures. So you guys are correct here. That's what it should have been. Great job. Must have taught you well, even though I can't type well. All right, so that's what we get through for today, I believe. So what we're going to do is we're going to rotate through. We're going to give you, let's see, we've got 50 minutes, 3 areas, just under, I cannot do my math, about 15 minutes because that'll give us a switch time, okay, in each area. So if you're in the red area, I'm going to come around, make sure you understand it. If you're in the red area, you're going to need to make sure you get me your quiz score before the end somehow. Either finish it in here if you understand it, and then when you move, let me know. Green and blue area, quickly do your quiz first, and then when you hit me, then I can help you with extra stuff, okay? And then in the green area, as soon as you finish your quiz, work together on that next part. Blue area, as soon as you finish your quiz, you can work with a partner next to you to help you, okay? All right, I'll bring up a timer, and we'll get going here.